Now let's focus our attention on specific heat capacity and what heat capacity under what measurement of what heat energy. And this one aspect of JAMB Physics syllabus that you must always see in your JAMB examination. So that before we go into it here, because we're going to do a lot of things, but before we go into it here, let me explain something here. Imagine you have an object, right? Now when objects gain heat, like heat is gained, or it is what is released, or it is what is gained, right? Or it is what lost, either or it is what lost, right? Or it is lost. Now when an object gain it or it is lost, now there's a change in what temperature, and that change in temperature depends on the mass of the object, right? So when we talk about specific capacity here, one, you need to what know the quantity of heat, right? Now you need to what know the mass of the what objects, right? And you need to what know the what specific heat capacity and change the what in temperature. So these four parameters is what you use when it comes to what heat capacity or specific capacity here. So I'm gonna break these two things down for you, but understand that now the formula to use when it comes to what heat specific capacity here that relates what the Q, the M, the C, and change the temperature is what Q is equals to what M, the mass, times the specific capacity times change what in temperature. Is okay. So when I talk about specific capacity, this is what should come to your mind, right? Now this can also be written as, because here Q is equal to what heat, the heat release or gain, right? And it's measured in what in joules. It's measured in what in joules. M, mass, and mass is measured in what in kg, right there. Now when the question is being given to you and gram is being given to you, you have to convert to what you have to convert gram to kg by divided by what 1000, right? Now here C is called specific heat capacity, right there, specific heat capacity. And now this is the what unit here. It can either be joules per kg per degree centigrade or joules per kg per kV. You understand? So these are what various units, in the sense that temperature can either be what in kV or in what in degree centigrade. Now here change in theta, which is what change in what in temperature, change what in temperature, which is what T2 minus what T1 is okay. That is my highest temperature minus what the initial lowest what temperature that is being here, and it can either be what in kV or what degree centigrade here. Is okay. So now let's define specific heat capacity. So what is specific capacity here? Because specific capacity and heat capacity, they are not the same thing. Just now, so what is specific heat capacity here? So please take it down. Specific heat capacity of a substance is defined as the heat required to raise the temperature of a unit mass of a substance by 1 kV or by 1 degree centigrade here. So the quantity of heat required to raise the temperature of 1 unit mass of an object by 1 kV or by 1 degree centigrade is called specific heat capacity, right? The quantity of heat required to raise the temperature of 1 unit mass of an object by either what 1 kV or what by 1 degree centigrade here is called specific capacity here. Now so what is heat capacity here? The heat capacity of a substance is defined as the heat required to raise the temperature of a substance by 1 degree centigrade or 1 kV here, right? Now look at something here. Specific capacity here, specific heat capacity, which was summated as C, and you also have what called heat capacity, capital letter C, right? Now here it must be what 1 unit mass of that object here. So the unit of what specific capacity here is what joules per kg per degree centigrade. Do you understand? Why the unit of what heat capacity is what joules per kV or joules per what? Per degree what? Centigrade here. So here, there's a mass of the object. Here, there's no mass of the object, right? So how do you relate the two of them, right? How do you relate the two of them? Please pay close attention here. Now, how do you relate them here? So here we can say its capacity is, which is what? Capital letter what? C. Capital letter what? C is equal to what? Mass times specific heat capacity. Heat what? Capacity. Alright, there, very important here. So here you can say that capital letter C is equal to what? M times C. Very important here. So you now understand what we call specific capacity, heat capacity, and their what relationship here. Now, but our main focus in this class here or in this video here, we have to solve a lot of problem using this one, so that you know how to solve problem under what specific heat what capacity. Do you understand? So let's solve some key calculation. So now let's look at what these two set of questions before we move to what the next set of questions, right? So let's take about the first one. So I want to really like this so that I can see space to solve my question here. So what is the quantity of heat that will be given at if a bar of brass of mass, right? Mass 390 gram is cooled from 95 degrees centigrade to 38 degrees centigrade here. Now look at what the specific heat capacity. Now I want to know something here. That now the mass is what? The mass is 390 gram, right? Now whenever a question is given to you and the mass is gram, you have to convert to kilogram when it comes to physics. And to convert to kilogram, you have to divide by what? You have to divide by what? 1000. So if you divide it by 1000, here we have 0.39 kg. Hope you understand. Now, yeah, our temperature change here is going to be what? The highest minus the lowest. The highest minus what? The lowest. So going to be what? Here we have what? 95 degrees centigrade minus what? 38 degrees centigrade. Just that. So let's get our answer. 95 minus what? 38. You have 57. 7 degrees centigrade. Just that. So the temperature change is always what? The highest minus what? Minus what? The lowest. Now, here specific capacity here, which is C, which is what? 380, right? Joules per kg per kV, right? Now you are not going to alter anything here. You are going to use it like that. The only thing you are going to change is this what? Mass here, but every other thing remain the same. Although here is what is degree centigrade here, you are going to use it like that. It does not appear in the calculation. Hope you understand. So now what they say to calculate the quantity of heat Q. We are being asked to calculate what the quantity of heat, which is what is Q, right? So what is the formula here? Q is equal to what? MC theta, right? Change what temperature here. What you want to do here is what in picture what your values. Q equals to what? My M is what? 0.39 times my C. What's my C? 380 times. What is my change in temperature here, which is what? 57, right? So what will be the answer here? So you have 0.39 times 380 times 57. So you have 8447.4 joules. That is the what answer, right? 8447.4 joules. Do you understand? So this is now the what? This is the what? The answer. Hope you understand. So you can see how easy it is. Now the same thing here, the same thing I'm going to do here. How much heat energy will be needed to change the temperature, right? Of mass. Look at the mass here. M is equal to what? 275 gram, right? You have to convert to what? To Kelvin. No, you have to convert to what? To kilogram by divide by what? 1000 here. Which is going to be what? 0.275 kg, right? Now my temperature here. This one is already what? Change what temperature here? Change in temperature is what? Is already what? 75 Kelvin. 75 Kelvin, right? Now my specific capacity here, which is C, is what? 2130 joules per kg per Kelvin. What be your stance? So they're asking about the heat, what the energy, the heat. It's okay, heat energy, right? So here we have Q equals to what? MC theta, right? Change the theta here. You're going to be at 0.275 times. Here we have what? 2130 times 75. What is the answer here? Here we have 0.275 times 2130 times 75. Here we have 43931.25 joules. This is not what the answer here. So you can see how easy it is. Now, question like this under what specific capacity is very easy here. So you still have two more questions under this what video that we want to solve here. So let's solve the next question. Now let's look at what the third and fourth question here, right? So let's look at what the third one here. Calculate the final temperature of 2 kg of alcohol at 25 degrees centigrade when 20160 joules of heat energy is added to it. Now the specific capacity here, right, you are being given here. So if you look at it very well, what they say you should look for, right? So solution, right? They say calculate what the final temperature, we got theta 2, we got the final what temperature, right? So the mass, right? The M, which is what the mass is, what is 2 kg, right? That is my initial temperature here. You want to go to 25 degree what centigrade, right? So my Q, which quantity of heat, is what 20160 joules, and my specific heat capacity here, with my specific capacity what 2520 joules per kg per kV, right? Now, how do we solve this thing here? How do we calculate what the final what temperature here? Understand that change in temperature is equal to what theta 2 minus what theta what 1, final minus what initial, right? Now because I'm being asked to calculate this guy here, if I should what make this guy the solve formula here, so my change in theta here, so my go to what theta 2 is equals to what change in theta plus theta what 1 is okay. So this is the formula I'm going to what make use of, right? So once I know this one here, because my initial temperature is going to be 25 degrees centigrade here, right? So what I want to do now is to calculate what my change in temperature. I will know that Q is equal to what M times C times change in what in temperature, right? So if I should what make this change in temperature, you would solve formula here. Change in temperature is equal to what Q over what MC. As easy as that, you can see how easy it is here. So what I want to do here is to impute what my values here. So what I want to do here, I just want to move to this other side here. So change in temperature is equal to what Q. Where's my Q? 20160 what joules over, right? Where's my mass? Where's my mass? My mass is what is 2, right? Times my C. Where's my C? 2520. So you have 2520 what 20. So let's leave out the unit here. Let's ignore the units. It's okay. So what would that be your change? So let's use our calculator here. 20160 divided by, here we have 2 times 2520. Here we have what 4 degree what centigrade here, right? So that will go to go by 4. So my change in temperature here is what 4 degree what centigrade here. So how do we get my final temperature here? So here we have theta 2 equals to what my change in temperature, which is what 4 degree centigrade here, plus my theta, we got 25. Here we have what 5 degree what centigrade, which is equals to what 25 plus 4. Here we have what 29 degree what centigrade. So that is the answer here. So you can see how easy it is. You can solve problem under this one here. So we are done this one here. So let's solve the last one. Let's solve what the last question. Let's solve the last question. The last question is very easy. It's that the temperature of the pie of metal of mass 12 gram is raised from 10 degrees centigrade to 110 degrees centigrade when it absorbs 108 joules of heat energy here. Determine what specific capacity here. So she will determine what the specific capacity here. So my mass is what is 12 gram, right? Of course, I have to combine what gram to what to kilogram here, divided by what 1000. So we have 0.012 what kg, right? Now, my change in temperature here, change in temperature, you go to be what final minus initial, the highest minus lowest here, 110 minus what 10, right? So we go to be what 100 degree what centigrade here, right? My Q, what is my Q? My Q is what, which is heat, 108 joules. Then my specific heat capacity here. So they say you calculate what the specific heat capacity. That's what they say you calculate. Just a specific capacity here, right? So remember, Q is equal to what? MC change it theta, right? So since we have been asked to calculate my specific capacity here, so we're going to be what? C equals to what? Q over M change it theta. This is that. So yeah, what am I going to have here? Is that going to be Q, which is what? 108 over what? My M, what is my M? 0.012 times change the Q is what? Is what? 100, right? So what is the answer here? So you have 108 divided by, here you have 0.012 times 100. So you have 90. So you have what? 90. It must be what? Just per kg per kV. So 90 joules per kg per what kV, right? Now these are they solve this question here under this what topic here. All this video is helpful. Please, if you are not subscribed, kindly hit the subscribe button. So whenever I upload a new set of video here, you'll be notified that a new set of video I've uploaded. Right? If this video is helpful, please leave a comment section that this video is helpful. Thanks for watching. Now our next one is going to be what? The mixture of the next thing I want to look at is method of mixture, where I'm mixing two things together, either solid, liquid, or liquid solid, right? What is what transfer what temperature? That is going to be our next video. Thanks for watching. Hope to see you in the next class.